Thank you for waiting. So tonight is November 14th, the much anticipated CDR for the 2008-2019. Our presentation outline as follows is we're going to start off with a project management introduction, then we'll go into our department presentations, followed by a 30-minute intermission, and then we'll have our question and answer period. Our project management introduction starts off as me defining the slides that are going to be demonstrated in this presentation. So we're going to go over again our corporate structure, and we'll talk to you about our sponsors, our budget, and the fundraising we're planning on. We're going to define what the CDR is. We'll have a PDR review. We'll show you our projected timeline. We'll go over the material specifications and decision matrix again. I'll give you a brief summary of the loading scenarios that the team used for their analysis. And then this year we're car number 50, very appropriate, being CSUN's 50th anniversary, and we'll be giving you the features and what you'll see on the 2008-2009 car. My name is Todd Hartunian, and I'm the project manager of the team. My core responsibilities are team management, financial management, and I handle the public relations. Being a small team, I've stepped up to provide secondary support for machine work and welding. Again, a review of our corporate structure from PDR is Dr. Prince is CEO, below him is our project manager, and we have our 4 chief engineers. Below them, they have individual engineers who handle the grunt work, as they say. Our team total is 14 members as of now. So far, our 2009 sponsors, which we must thank because without them, this car would not be possible. Dynamo Aviation, SciTech Engineered Materials, and Yamaha Motor Corporation have already been so helpful. And again, we'd like to thank Swift Engineering, Gearhart, Thermal Technologies, and ZMC for the service work that they do for us. Our current budget so far is $27,500. That's with our $3,000 estimate from the University Corporation that we're anticipating. That's a little bit of a lowball figure, but it's our play it safe number as well. So the fundraising we're planning on doing this year is a CSUN barbecue, and we get some money for some visiting workshops from other schools, and we're going to have to file for AS supplemental requests to help finish off the car and make sure we don't run out of funds. So, CDR, what does it mean? The CDR is a critical design review. It follows our preliminary design review, our PDR. The purpose of the CDR is for you to see all the work, the many hours we've spent, what we've been doing, the analysis we've run, and after the CDR, we'll have to go into design for manufacturing review, where we'll closely double check all the analysis, make sure all the new designs are easy to manufacture, and then from there we'll begin our manufacturing. A review of our PDR, for those of you that weren't here, this was ideas that were formed doing research and initial concepts that we would like to have done. And it's not something that you may see on the car. I'll let the departments get into details about this. But our powertrain department had mentioned a carbon fiber intake as a backup design. Our chassis department wanted to change the front monocoque and lighten the rear monocoque. Our suspension department wanted new mount points, a redesign of the uprights. The controls was talking about adjustable pedals and aluminum brake rotors. So after tonight, you'll have a clear standing of where our car is going to stand and what you should expect to see. A brief overview of our project timeline. We've already finished our PDR, our CDRs tonight. We begin design for manufacturing review as soon as Monday. Manufacturing will begin the 1st of December, and our anticipated date for the vehicle to touch ground is March 29th. We would like the testing to begin April 1st to allow us the 75 days of testing time that we chose for our first goal. So again, a brief summary of our material decision matrix. We used a scale of 1 to 8 for the materials, and we broke it down into categories: their strength, their modulus of elasticity, price, and so on. And we use this to help us determine what materials were appropriate for a certain component. It it's important to know that just because a certain materials rank so high, it doesn't mean that it's really the best choice. Even though steel is really one of the highest ranked components, it's more because of its price. Aluminum is typically the material that you see a lot of on the vehicle because it's lightweight, it's relatively inexpensive, and it's very easy to machine. Carbon fiber is a material that we love to use because it's lightweight, it's strong. The problem with it is you can't machine it, it has to be molded, and you definitely can't weld it, so it can't be used everywhere. So as engineers looked at this decision matrix, they had to determine the best material for the purpose. This is a quick summary of the loading scenario that the engineers used on the vehicle during their analysis. These values were obtained from the tire forces, and we used two scenarios: acceleration, cornering, and hitting a bump in the rear, braking, cornering, and hitting a bump in the front. The suspension department will go into more details of the loading scenarios. This is a summary of our front forces for you to see. These values were used by each individual engineer to perform their analysis on a certain component. But it's important to note that not every value was used during analysis. The proper value had to be used, such as the upper A-arm forces had to be used on the uprights. You wouldn't want to use the braking forces on that particular component. Excuse me, that particular component. These are the forces for the front. We have very similar forces for the rear, although their values are different, the categories are the same. So the general data for car number 50 this year, we have a theoretical wet weight of 446 pounds, an 11-inch CG height, with our typical front and rear track of 48 inches, a 66-inch wheelbase, and our overall length of 110 inches. The features that you'll see on the vehicle, broken down by department, is a rebuilt Yamaha R6 engine, a full titanium exhaust this year with crossover pipes. Our suspension will have a rising rate suspension and be a good camber per degree of roll. Our controls, we're going back to the cable clutch design, and this year's chassis torsional rigidity is better than last year's, but we have a larger chassis and our theoretical weight, again, is lighter than last year's. Our mass budget broken down somewhat by department. This is how we came up with our total wet weight. And as we enter the manufacturing phase, will be broken down into, everybody's going to have a responsibility. But again, being a small team, we're going to have to multitask. So although we have 4 CNC machinists, those guys are going to share the task of welding, wiring, and assembling the vehicle. That's all right because everybody's very motivated and ready to get dirty. So I've included some SolidWorks models of our 2009 car. The first one here is just a cross section of the middle of the chassis showing our the internally mounted suspension components. Again, this is another view of the vehicle and what we expect it to look like. All of our molds will be based on the drawing, so it shouldn't change much from here. And this is just our top view of the vehicle so that you can see the shape of it all. I'm going to now go into our department presentation, starting with powertrain.